As mentioned, I'll be discussing and presenting our work that's the culmination of about 2 years of research and development on the SmartOR, which is a distributed sensor system that we've installed in active operating rooms at our home institution. I have no disclosures. So, as we all know, operating room costs are really expensive, running now about $100 for every minute of active OR time, and the complex environment of the OR suite, things such as efficiency and, of course, safety are paramount. Every day there's cases that are being changed, add-ons, there's cancellations, all these things need to be dealt with on the fly. And at the same time, you have different OR managers and OR management companies trying to converge all this data so that one glance at the operating room's front desk, you should be able to see what status cases are at. As of right now, all of these status updates, where the patient is, where the case is, are all done manually with a nurse entering in patient in-room time, first incision time, out-of-room time, things like that. So we identified this and we saw that there was a need. We need something like an automated tracking system to understand what step of an operation is at without people entering in data to ensure that things are going to be put in accurately and in a real-time manner. We also wanted to have a system that automatically identifies these steps. At the same time, as it does this, we hope to have a system that collects all this information so that we are able to look at this information either retrospectively or instantaneously and see, is there something we need to change now, or are we looking at something that needs to be changed down the line? And most importantly, of course, we don't want to affect anything that happens in the OR or the process, so we want it to be non-invasive and non-obtrusive. So we first segmented the operating room cycle into the different steps that we have here as a way to try to target each one of these specific activities as a state of room change. So everything from the patient entering the room to intubation to the laparoscopic portion of the operation and the reversal as the patient ultimately exits the OR and the room is clean to start the cycle again. By doing so, what we did is we looked at specific steps of the procedure and looked at a specific event that was a landmark of this procedure. So the patient entering the room, we designed a pressure sensor for the floor that lets us know when the bed enters the room, automatically marking that time in. We also used a small motion sensing camera that lets us know when the bellows are moving, which lets us know if the patient's been intubated and thus the case has started. That camera also detects the change in the light intensity in the room to let us know if the laparoscopic portion of the case has begun. And these same sensors are used in the reverse order for extubation as well as patient exiting the room. For this study, we also added in a generalized motion sensor that we could use to see what the different events and people were doing, at least in terms of room occupancy over the course of the study. Here's a brief picture of what the sensors look like installed in one of our active ORs at Houston Methodist. Everything's connected wirelessly, so none of it required the hospital system and allowed us to access and look at the data without interrupting any of the cases at any time. On top of that, we also added a RFID sensor system in the preoperative holding area, and also the participating surgeons all had RFID tags. And the idea is we wanted to see when patients were identified in the preoperative area compared to when they rolled into the OR, knowing that this is just one data point in a complex series of events that may happen before a patient enters the room for a first case start. So we installed these sensor systems into 2 operating rooms that were high volume and where the predominant amount of our laparoscopic cases were done at Houston Methodist. And these are also the same rooms that ultimately are used for emergency cases. Systems are running 24 hours a day, 7 days a week, and as we collected the data, we correlated this with the patient's electronic medical records so we know what type of case was done. The systems were installed in November of 2014, and the data that we present here is processed through January of this year, although we continue to collect data now. We collected data on over 1,000 cases, about half of them laparoscopic, and also identified 374 turnover times. As the first data point, using the RFID detection system, we're able to see that for a 7:30 first case start, we detected our staff surgeons entering the preoperative area at about 7:20. The mean first case start time, based on our system, when we calculated this, is that even though it was scheduled to start at 7:30, 79% of them started at 7:40. First, starting with the turnover time, of the 374 that we analyzed, we saw that 72% of these exceeded our institutional goal of 30 minutes. So most of the turnover times that happened during the course of the day were above the ideal time frame, indicating a potential opportunity for improvement. Going next to the laparoscopic cases, we included all cases that were laparoscopic, short, long, but even so, you can start to see a distribution of where most of them fall. And then there's a couple outliers that you can see exceed sometimes upwards of 10 hours. By collecting all this data and looking at it retrospectively, we can quickly pick out what are outlying cases and go back and see if these were opportunities where something could have been changed or some aspect of the operating room system and flow be improved. Using our sensors, we're also able to segment the OR cycle, like I mentioned earlier. So we broke it down into in-room time to intubation time, intubation to initiation of laparoscopy, in the end of laparoscopy to the extubation, and finally the patient extubated to exiting the room. Understanding that when the operation is actually happening, there's a lot of complexities that may happen there. But if we focus, for example, on the time from extubation to the patient exiting the room, the spread is relatively tight. The patient has met criteria for extubation, they're awake, and really what needs to happen is that they need to exit the room to recover and pack you so the room can be turned over. But in our study here, we saw that even upwards of 11% of the time, these cases fell greater than one standard deviation beyond what we saw as the mean, with some cases exceeding an hour for the patient standing in the room. In this specific case that I pointed with the green arrow, we went back and looked at that case and saw that the patient stayed for an extended amount of time because the ICU and the PACU did not have a bed ready for them. Looking a little bit deeper at laparoscopic Roux-en-Y cases, you can see the spread is a little bit larger, but as we move through and collect more and more data on specific cases, we hope to start to be able to look at this, develop a statistical model perhaps, and use it as a real-time method for identifying if cases are going longer, allowing the OR manager to reallocate resources. Finally, in brief, another interesting thing we saw is as the day progresses, we found that although it changed just a small amount, that cases seem to progress a little bit faster over the course of the day. And our hypothesis is that perhaps maybe as the OR system gets smoother and people begin their day and get used to how everything flows, that things move a little bit faster and more efficiently. So in closing, future directions, we're working on refining our hardware and data processing optimization to get closer and closer to real time. And we hope to ultimately distill the data down into a user-friendly presentation method. So like a new OR management system where we can leverage our sensors to do updates and at a glance be able to see what state the operating rooms are in. And ultimately we want to increase this to other operating rooms and institutions and continue to collect data to build a statistical model and maybe build something that can improve our current state of systems. Thank you very much.